Hello, this is Dr. Adalberg, and this presentation is sorting with part identification. This is Lab 9 online, and we are using RoboDK software for simulation and offline programming. The lab objectives include configuring the station, where we'll download a robot, open gripper and close gripper. We'll download table and 2 boxes. We'll reduce the size of a box by a factor of 1/8, so we'll have large and small boxes. We'll mount the robot and the 2 boxes on the table, place the 2 boxes arbitrarily in location 1 and location 2 on the table close to the robot. Then we'll write a user interface program to choose the box's location. Next, we'll write a program to locate the small box and place it on top of a large box. And we'll do it by going to location 1, measuring the box, again, going to location 2 and measuring the box there. Then if the small box is in location 2, we will grip it and go back to place it on location 1. And if the box is in, the small box is in location 1, we'll go to location 1, grip it, and come back to location 2 and place it on top of the large box. We want to simulate the process and write a report. 2 notes that we like to notice here is that the identification of the small box location will be done by finding the distance between the gripper and the small box using POSE and RoboDK API methods. And we'll also use the hide and show commands for the open and close grippers when we pick and place in order to visualize the pick and place gripper opening and closing better. The station configuration includes a robot, table, and a small box and a large box. We will write the HMI program to choose the location of each one of these boxes. With the Python program over here, we'll have a message box which will open up, and we'll say choose position of the big box, either left or right. Then when we click on left, it will assign the letter L to it, and if we click on right, it will assign the letter R. If the left-right is chosen, then we'll go to reset 2. If right side is chosen, we go to reset 1, and then we could quickly take a look at the way it is reset. We see that we have over here reset 1 is the large box is on the right hand side, and reset 2 is the large box is on the left hand side. We will use this, of course, in a program. The next thing we like to do is writing the program to identify the size. This is again a Python program, and the complete program that we will write include the following subroutines. We will rearrange the boxes, then we'll go measure in station 1, go measure in station 2, and then we will place whatever we need to place the small box on a large box. And these will be the subroutines in order to conduct this place, and we'll operate the entire process with the main program. The Python program will include the uploading the identification of the gripper, and also finding its position. This is one of the methods which Python is using, and we get that at RoboDK with a set of commands that we could, by clicking here, find them. We'll see it over here. When we go down to this link, we'll have quite a few examples, and then at the bottom we'll see all the methods and we also have a whole list of vector algebra matrix operations which are useful in this process. We will then define the location of the small box and use a vector algebra definition which takes two vectors of the position of the center of the origin of the box and the gripper, subtract the two three-dimensional vectors and take the norm, which is just the side, define that as D2, and then if the small box is detected, D2 is greater than 200, then and that is because the gripper is on a station 2 and the small box is in station 1, so the number is large, then the program is going to call place 1 and 2, and that is the subroutine here, and vice versa. If the small box is not detected there, then we go to again and pick it up right there and place 2 on 1. The Python program allows us to run the so-called Python shell, and this is very useful for debugging. When we run the shell during the operation, then we could set up with the various positioning over here the robot at any point, and if you like to know what is the distance between the parts, then we could use the shell and also have a print statement over here that print out the distance on a shell. As we see over here, it's 200 and 200, so at the measuring place it was 400, and that's the distance that we get here. Then we simulate the process. We'll see that in a minute, and write a report including the objectives, the screenshots of the scene, the box range program, identification program, and also showing the simulation program. The reference is a in-class similar lab which we are using at MET 415. We could take a look quickly and see here the video. This is the setup. This is the scorebot. We have the large cylinder, the small cylinder. The robot is coming in to the first stationing, measuring with the sensor built in within the gripper, the diameter, then going to the second one, measuring its distance, then within the software comparing the two numbers, and then coming back to pick the smaller one, and then placing it on top of the large one. So that's the in-class operation. The robot decay process, we have here the main. We click on that, we click left, and then the robot comes in, takes the measurements, pick up the small one, and placing it on the large one. And if we choose the right, then the robot measure both of them, goes back to the small one, and put it on the large one. This concludes our presentation, and we will look forward to see the students repeating it as a lab tutorial. Thank you.